All right, here we are, Math 2 people, back again, and it's the last week of any new material that we basically have to cover for the rest of the year, which is kind of an exciting place to be. What we're really going to do is basically put everything together so far, usage of Pythagorean theorem and all three trig functions that we've worked with, so that whole SOHCAHTOA thing, that sine, cosine, and tangent, all three of those are going to get used, and it's going to vary based on each problem. We're going to do a little bit of like practice with determining which one to use based on given information. And then because of algebra and how much we all love that, we've got to do a bunch of stuff working backwards. Okay, we're going to use um, this information about side lengths to go backwards to find angles. All right. As always, the teal slides are going to be sort of your toolkit stuff, and I can upload these once we're done. So, just to start off, though, page 558, example 1. I've got a triangle here, ABC. Let me go move this guy over. And I'm asking, determine which of the two acute angles has a cosine of 0.5. So let's break that down. It has to mention acute because everything we're doing is a right triangle. So one of the angles is 90, that's angle C. So it's basically now narrowed down to, is it A or B that has a cosine of 0.5? So I'm just going to write these out, and we'll go in alphabetical order just to see. So I'm going to do cosine, oops, if I could spell, that would help, of A. And then I'm also going to copy that, and I'm going to make it cosine of B, and we're going to write both of these. So cosine of A, actually drag these lines over here. Both of these are going to be fractions, and in both cases, since it's cosine, that cosine relationship is the adjacent side, so the one next to an angle, the leg that's touching the angle, divided by the hypotenuse. So if I'm looking from A, my adjacent side is this square root of 3 right here, right? That's the leg right here that's touching angle A. So my numerator is square root of 3. My denominator is the hypotenuse, which is opposite the 90, so that's 2. If I were to do the same thing for cosine of B, I'm looking now at this top angle B, the side that's touching it. The adjacent one is 1, and the hypotenuse across from the 90 is 2. So which of these two acute angles has a cosine of half? What we're looking for, the answer is actually angle B. Because if I do cosine of B, so cosine of that angle, it comes out to 1 over 2. Turn that into a decimal. There's your 1/2. Okay. Now the next part here, it's going to be a teal slide, so it's come back and look at this later, but don't freak out. Okay, there's a lot going on here. So there's this sort of chart on page 558, but I like kind of phrasing it sort of differently. We're going to talk about these ideas of inverse tangent, inverse sine, and inverse cosine. We need them because normally the way that we did it, so like we'll talk about sine here. We started with sine of an angle is the opposite side divided by the hypotenuse. That was some stuff from last week. If I know the angle, I can basically set up and find, we did a whole lot of algebraic work finding either opposites or hypotenuses, and that was even on your quiz and a whole bunch in the homework. Given an angle, you can figure out one of these other pieces. What the inverse does, like right now, if I ask you to solve for theta, I've had a lot of people in the past say divide by sine. Well, you can't do that. Sine's a function, so it's kind of like, think if you had something squared, how you take a square root of both sides. We have to take an inverse sine of both sides, which is this little guy right here. It's this sine, but then it has a -1 exponent before the parentheses. So you read that as the inverse sine, and then look what's different here. It used to be sine of theta is opposite over hypotenuse, and that's now moved to inverse sine of opposite over hypotenuse equals theta. So basically, the thing that undoes sine is called inverse sine. And if instead of giving it an angle, if I give it a ratio, it tells me an angle that matches. There's going to be a lot of practice with this, so right now it's a little crazy. Don't freak out too much. Cosine of theta, or any angle, is the adjacent side over the hypotenuse. So inverse cosine is going to basically flip that around. Inverse cosine of adjacent over hypotenuse equals the angle. All I'm basically doing is using an inverse of the function because it undoes that, and I'll show you algebraically how that looks on the next slide. And then instead of giving it the angle, you now give it the ratio of the side lengths, and it spits out the angle, right? Because it used to be, give it an angle, it tells you a ratio. We're flipping that. So now it gives you a ratio, and it can spit out an angle, so we can get both pieces either direction. You can probably guess what's coming next. If we have tangent of theta is opposite over adjacent, if we flip that to do the inverse tangent and give it opposite over adjacent, it will spit out the angle, okay? So you can, if you already know your sine, cosine, and tangent super well, it's really just switching where these things go and if it's an inverse sine, right? Like, it's not like the ratio of side lengths is changing that you're using. Sine was always opposite over hypotenuse. So inverse sine of those same sides, opposite and hypotenuse, gives you the angle. Cosine and inverse cosine are still using adjacent and hypotenuse. Tangent and inverse tangent are still using opposite and adjacent. Okay. So page 558, example 2 here. It's asking, we're giving you just a bunch of acute angles. We say acute because it's a right triangle. One of them has to be 90, which means the other two have to add to 90, so they both have to be less than 90. So they're acute. All we're asking for here is basically use that same stuff to kind of figure out what the value of the angle is. It says find the measures of angle A, B, and C to the nearest tenth of a degree. Now I want to bring this up. I noticed on the homework last week, a lot of people put in like 4 decimal places, even though it said round to the nearest tenth. So big ideas math is like, no, you're wrong. But if you look at the numbers, like, you know what you're doing, but it's expecting to the nearest tenth. And it's not able to understand if you're putting in too many decimals because you didn't read the directions all the way. Be careful of that piece. On a quiz, I can be a bit more forgiving, but if you're putting all your answers in, you're thinking, what the heck, I thought I had all this, and it's not coming out right, and make certain you're following those directions, okay? So, I'm going to, ooh, goodness, we don't want to do that. For this very first one here, tangent of A is 0.75. I'm going to showcase something that like is how I was taught and makes sense, and it's like why the inverse tangent works. I'm going to show you what this looks like, make an analogy to like another style of algebra, and then we'll kind of move through and solve the rest here. So let's say that I had, just for an example, like 2x plus 3 equals, I don't know, let's call it 9. If I had that equation, and I'm trying to solve for x, right? It's right here multiplied by the 2 and then added by 3. Algebraically, what are we going to do? We're going to subtract a 3 from both sides, which is going to give me 2x equals 6. And why did I subtract 3? Well, it's the inverse operation of addition. I now have 2x equals 6. What am I going to do to get that by itself? I'm going to divide both sides by 2. Why are we doing division? It's the inverse of multiplication. So you get x is 3. Right? That same process is what we're going to basically try for this tangent piece here. Let me go ahead and group those. We'll probably get those out of the way soon enough. I can't just, it says tan of A. It's not tangent times A, that doesn't make sense. It's tangent of A. So I have to get rid of the tangent, and I can't do it through division. So what I'm going to do is I'm going to take that, actually, let me just copy this. The advantage of the computer. Come on. There we go. So if I take my tangent of A, I need to find something that undoes tangent. What is that? Well, as we talked about in that previous slide, the inverse tangent. Now, this is where it's going to look really weird. If I started with tangent of A, to undo this, what I would do is I would take, and I'll put this part in a different color once I'm done. Ooh. So let's make all of this part blues, just so you can kind of see the difference between these. You don't have to write all this. It's how I was sort of taught. But if you choose to do it a slightly different way, oops, that's totally okay. So what I'm doing here is both sides, my left and right side, are exactly the same. They're worth the same amount because that's what the equal sign means. What I'm instead now doing is I'm taking the inverse tangent of both sides. That same idea of what do you do to one side, you match it to the other. If I take the inverse tangent of tangent, what's going to happen? Those pieces are going to cross cancel. So what do I really need from this point? I'm going to copy this step down. I now have this guy right here. A, the angle, is the inverse tangent of 0.75. That 0.75 is the ratio of the opposite over adjacent. Now, if you've gotten to this point, great. Basically, if we're asking you for an angle, you're just going to do an inverse tangent of whatever the other side is. It's always going to match up that way. Time to type this in a calculator. I'm going to pop over to my calculator here. Make certain I'm in degrees, depending on what type of calculator you're using. So since this is the TI-84, I need to turn it to degrees. Now, inverse tangent, if you look in mine, it's blue right above where the tangent button is. There's an inverse tangent. So I can hit second and then that button, and it says tan with the -1 exponent. That's an inverse tangent. I'm going to put a 0.75 in, close the parentheses, hit enter. So what that means is this answer, it's asking to the nearest tenth of a degree. We just found the measure of the angle at 36.869. Well, if I round to the nearest tenth, that 6 is going to tell me to bump the 8 to a 9. What's A actually worth? What do we just say? 36.9 degrees. So let me 36.9 degrees. Now, this very first step I showed where I'm doing the inverse tangent of A equals the inverse tangent of 0.75, most people like to skip that, and that's fine. I want to showcase where it is. I'm going to basically do it for this page, and then after this, I'm not going to do that step anymore. That's really what's happening, but it basically just moves the tangent to the other side, but with an inverse instead, okay? So, let's try this guy. I have inverse sine, or I'm sorry, I have sine of B, it's 0.87. Well, I want to solve for B. What's going to undo a sine? An inverse sine of both sides. So what that would look like would be this. Again, I'm doing it sort of the longer way this time, and only for this one, just to showcase like why it makes sense. But you do not have to do this piece. If I take the inverse sine of both sides, that algebra still holds. What happens? Inverse sine and sine cancel out. So what do I really get? I get B, my angle all along is inverse sine of 0.87. So I'm going to now this time, instead of doing the TI-83, I'll do it with that Desmos calculator. If you're using the Desmos calculator, you need to click this function button right here. And then we see right here, it has my inverse sine now on that left side. So if I hit inverse sine, and then I go back to main, now I can type, what did I need? 0.87, it's the ratio of my opposite and hypotenuse. And it's kind of auto-calculating, right? It says at this point now I've got 60.45. Round that to the nearest tenth, that's 60.5 degrees. .5 degrees. So you're going to start to notice some patterns. Really, all I'm going to do is basically the cosine is going to move to the other side, but as an inverse, because that's what undoes this cosine. So let's copy this guy. Come on. Again, you don't have to do this step that I'm showing right here. I'm showcasing why this makes sense to do. Oops, that's too small. This is, you're doing the same algebra to both sides, but after this point, most people don't show this part. I gotta get rid of that 12, that's not what I want. Why does it work? Inverse cos and a cos next to each other are gonna cancel each other out, so what am I gonna really get? At this point, C, my unknown angle here, is the inverse cos of 0.15. So if I go back to my Desmos one, I go to function, inverse cos is now in that second column. Go back to main, and I'm going to type, what was it, 0.15 I want to say? Yeah, 0.15. Oh no. I need to put that in the parentheses, 0.15. Saying 81.37, which would round to 81.4. That's what C is going to be. 81.4 degrees. Let's check the same thing on the TI-83. Inverse cos of 0.15. The inverse cosine, I'm still have to hit second and then the cosine button to get the inverse. I'm going to type a 0.15, close my parenthesis. Hey, 81.4. Right, round to the nearest tenth. That's the process. Seems like we got somebody here. Cool. So the next ones I'm going to it's page 559, monitoring progress, number 3 through 6. If you're kind of watching later, I would say pause it, try and do these on your own and see how they match. I'm going to do the sort of quicker version at this point now. What do I need for this sort of next step here? For number 3, tangent of G is 0.43. That means, again, if you haven't tried this on your own, you're watching the video later, go back and pause it. G is the inverse tangent of 0.43. That's it. I literally need to type this thing into a calculator. Second, I'm going to hit the tangent button. I'm going to get my 0.43. 21 point, because we're going to the nearest tenth again, you have 21.3 degrees. That's it. Number 4, it says sine of h is 0.68. I'm trying to solve for h, so what undoes sine? An inverse sine. I'm going to copy some of this over here. So it's going to be h equals, I should capitalize that, the inverse sine now of, and now it's a 0.68. Right? Do you start to see the pattern with some of this? I'll use Desmos this time. Type it in. What is the inverse sine of 0.68? Let's clear all this. Go to function. Inverse sine of, go back to the main, 0.68. There's the parenthesis. There we go. It says it's what, 42.84, which would stay at 42.8. I should clarify, 42.8 degrees. Oh my goodness, 42.8, not 425.8. Okay, last one, cos of k is 0.94. So what's this guy going to look like? Move this down here a little bit. K is going to now equal the inverse cos of the 0.94. That's going to end up being like, if I had a fraction, if I cleaned that fraction up into a decimal, my adjacent hypotenuse would turn into that 0.94. What is the inverse cos of 0.94 going to be? I'm doing the Desmos one here, so go to the function, type a 0.94, and we get 19.94, so rounded to the nearest tenth would be 19.9 degrees. That's the first part, okay? That's how an inverse function works. The inverse is going to undo sine, cosine, or tangent, so there's an inverse cos, inverse sine, inverse tan. It moves to the other side, and instead of giving it an angle, you give it a side length ratio, which is what these 0.43, 0.68, 0.94s are, and it spits out an angle. All right. The little dog is like right here, and he's dreaming, so there's a lot of weird noises he's making. Okay. We're going to go a little bit further with this guy. This is kind of page 558, monitoring progress number 1 and 2. It says we've got this triangle, DEF, and I want to first answer like which angle has the correct ratio. It says this, for number 1, the sine of the angle is 12 over 13. Then I want to find the angle measure. So let's make this font a little smaller. Currently, I know this. I know sine of some angle. So let's do, no, I'll leave that blank for now. I'll come back to that. It needs to equal 12 over 13. I'm going to do the sideways fractions just for space here. I'm asking which angle has a ratio of 12 over 13. So if I were to just go alphabetically, E, I'm looking at this angle E right here. What side is opposite from E? The sine's opposite over hypotenuse. My opposite side is 12. My adjacent is 13. I'm sorry, my hypotenuse is 13. So we basically got our answer right there. Which angle has a sine of 12/13? It's E. If you did F, its opposite side is 5 and hypotenuse is 13. So that's not quite what we're looking for. It says then find the angle measure. So I have sine of E is 12/13. I want to get rid of sine, so what are we going to do? I'm going to take the inverse sine of both sides, and what it's going to do, move this guy over here. So I take the inverse sine of 12/13. That's it. That's all we're going to do. Let's go to our calculator. Let's type it in. Inverse sine of 12/13. You might be thinking, well, hold on, it's not a decimal. That's fine. It doesn't matter if it's a fraction or decimal. Inverse sine of 12 divided by 13. 67, let's keep in the same thing, round to a 67.4 degrees. So we just figured out what E is. There it is. We basically looked at both angles. E was the one that matched because we said, well, find me an angle where sine is 12 over 13. Opposite 12, hypotenuse 13, so that had to be angle E. Try number 2. The tangent of the angle is 5 over 12. Tangent is a ratio between the opposite divided by the adjacent. All right, so I'll go ahead and write this out. Tangent of an angle, I'll leave it blank for now, is going to equal my opposite divided by my adjacent side. So I'm looking for something where when I look from the angle, the opposite side is 5 and the adjacent side is 12. If I come back up to my triangle here, pick a different color, from angle F, the opposite side is 5 that it's not touching, and 12 is the leg that it is touching. So we're really talking in this case about tangent of F. What was my opposite side? It was a 5, and the adjacent side was a 12. It says then find the angle measure. I need to get rid of that tangent. How are you going to do it? You take the inverse tangent of both sides. That's going to move the tangent off of the right side and make an inverse tangent, or sorry, off of the left side, make an inverse tangent on the right side. You literally need to type that in a calculator, and it's going to spit out a number for you. So we have inverse tangent of 5 over 12. So I'm going to do second tan to get to that inverse. I'm going to type 5 divided by, maybe, 5 divided by 12. 22 point, that's going to be a 6 because the 1 isn't going to round it up enough. What did I say, 22.6? Yep. There you go. It's making certain that you know all of your trig functions, sine, cosine, and tangent. If you need to undo a trig function to find an angle, like all the previous weeks we were basically finding side lengths, now we're flipping around and finding angles, you got to use these inverse trig functions. Okay. It's going to get a little spicier here. The directions say, solve the right triangle. Round decimal answers to the nearest tenth. Now, the phrase solve the right triangle is a little more involved. Oh, and this should be, I want to say page 559, example 3. What does it mean to solve the right triangle? Every triangle that you ever come across is going to have 3 sides, and it's going to have 3 angles, hence triangle. The size of the angle determines the size, or the side length. When I say solve the triangle, I want to know all 3 sides and all 3 angles. 6 pieces of information. We're only messing with right triangles, so really you're only going to have to find 1 or 2 angles and then the rest of the sides here. And there's a couple ways that we can kind of approach some of these. So we've got this triangle here where I know it's a 90. I have 2 side lengths, 3 and 2, and I don't have my 4th side. Fourth side, what am I talking about? It's a triangle, it has 3. Well, there's a couple ways we can approach this. Let's start by, right now I see it's a right triangle. I have 2 sides, both of which are legs, and I don't have the hypotenuse. You know what I'm going to do? Pythagorean theorem. If I do a squared plus b squared is c squared, right? That was how we started off the unit, right? Section 9.1. Just substitute. A squared is going to be a 3. B squared I'm going to call 2 to get c squared. So that's going to give me, what does that give me? 9 plus 4. Oh, goodness. I hit the right keys there. 9 plus 4 is c squared, which is going to give me 13 is c squared. What am I going to do to get c by itself? I'm going to take the square root of both sides. So I'm going to get square root of 13 is c. Great. I'll move that guy down a little bit. So now I have all 3 sides. I have one angle, which is 90. Let's find both other angles. Okay, this is now where the trig is going to come in. So in this case, Pythagorean was able to help me get my 3rd side. If you have 2 sides, you can always do Pythagorean to find the 3rd one. Okay, let's start with angle A, just going alphabetically. From angle A, I have a square root of 13, sure. Really, I have all three sides, so I can use any trig function that I want. However, since it gave me the opposite side from angle A, which is 3, and the adjacent side, which is 2, if I have opposite and adjacent, my brain's already going right to tangent. So what I would know right now is I could say tangent of A is equal to 3 over 2. That's true. Now, I could, instead of doing it this way, I could say, well, I don't want to use tangent. I just did all this work to find C, which is the square root of 13. What's going to relate opposite and hypotenuse? That would be sine. So sine of A would be a 3 divided by, ooh, this is going to be hard to write. I'm going to just delete that and write it with a pen. 3 over square root of 13. Now, I'm not going to simplify this guy for right now just because I can type it into the calculator and it's going to be fine. You might still not even see it that way. And you think, well, it gave me the adjacent side and I just figured out the hypotenuse. So you could do basically the same thing but with cosine, right? Cosine of A is going to be my adjacent side, which is 2, divided by my hypotenuse, which is the square root of 13. Any one of these will work to find A. The algebra is basically going to be the same sort of thing. What would I type for this first one here? Where if I go back to tangent of A is 3/2, what I need to do, A is going to equal the inverse tangent of 3/2. I'm going to hold on to that. I'm going to do the same algebra here. And I'm doing this kind of problem 3 different ways at the same time to show that they're all going to work. You're only going to have to do one. If I were to repeat that same process for the sine of A is 3 over the square root of 13, it's going to look like this. So it's a little hard to juggle some of the typing and this writing here. So you let me do this? Yeah, there we go. Right? In this case, A would be the inverse sine of 3 over root 13. Or, if we did the same process, I could basically get A is going to be the inverse cosine of the same angles that we had right there, the 2 over square root 13. Any one of these works, so whichever one you see, maybe you have a favorite trig function from all these or one that just sticks in your brain better, use it, that's fine. Let's go test these. I'm going to type inverse tangent of 3 divided by 2. Hit enter. 56 point, that'd be 3 degrees. Cool. Well, let's say you didn't do it that way. Let's say you did inverse sine of 3 divided by, I got to do square root here, 13. Be careful with some of the parentheses with this. Oh, we got 56.3. Okay. What if we were to do the inverse cosine then of 2 divided by the square root of 13? Right, I'm basically just changing, oh goodness, which trig function I'm using. And what do we notice? It doesn't make a difference, right? What does A come out to be? 56.3 degrees. We're gonna call it. We'll go with tenths for this. 56.3 degrees. So now I'm gonna come over here and I'm gonna label on my triangle that A is 56.3. You could do some more trig, just like we did to find angle B. I would use something else though. I know that one angle is 90, one angle is 56.3, and in a triangle, all three have to add up to 180. Here's what I'm going to do. I'm going to write 180 equals 90, because I already know that, plus, 56.3 plus whatever angle B is. If I add 90 and 56.3, that's going to give me 146.3. Right? Because now I'm just doing algebra. You can, if you want to do the trig, it'll work. Promise you that. What am I going to do to both sides to solve for B? Subtract 146.3 from both sides. Let's see what that's going to give me. I'm going to do 180 minus 146.3. 33.7 degrees is B. I realize there's a lot going on here. I could have done this entire problem and ignored all of these guys, right? I could basically group these. Let's group these, get them out of here. What I have right now is a completely solved problem. You could do it other ways. You could use any one of those trig functions. Once you found the angle, you can just do 180 equals 90 plus the one angle you have, and then you're missing one, and do some algebra. You could do trig to find the other angle. Any one of them works. That's the whole point. All of these come out to be the same thing. It's a nice thing is all of it works, so whichever way works best for your brain, use it. When it says solve the right triangle, I need all three sides. I was given 2 and 3. I did Pythagorean to find square root of 13. I have all three sides. And find all three angles. I was given 90. We did some trig. I chose to do tangent first, but we saw that sine and cosine, as long as you use the side lengths right, all gave a 56.3 degrees. Once I had two angles, I can do 180 minus the 90 minus the other angle. What guy's going to be left? My third angle. Solve the triangle. Give me all three sides. Give me all three angles. Let's do a few more. These are page 559, monitoring progress number 6 and 7. We're going to start with number 6 here. This is another right triangle where I've got two legs. I'm going to go ahead and find my hypotenuse right away. Every time I'm going to do a squared plus b squared. That's, I think, the easiest one for me to find all these pieces. Okay? So that's going to end up turning into, let's call it 20 squared, 21 squared. I do not know these numbers. I'm just going to go and add them all in the next step as well. So on the calculator, I'm going to do 20 squared. There we go. Plus 21 squared. That whole thing turns out to 841. Hooray. I don't think that's a pretty one. Is it? Let's see. Can I do the square root of 841 cleanly? I don't believe so. Oh, 29. Okay, so it is a perfect Pythagorean. How nice. If I take the square root of both sides, which I should probably draw in here, what do I get? 29. I'll lose track of some of those higher square numbers at this point. So great, we already know one side now. This last side, we just figured out 29. Last time we used tangent. We'll use a different one in this case. Let's say that now I have the hypotenuse. I'm going to try and find angle E. I'm going to use the adjacent side and the hypotenuse because I know both of them. I know it's a 21, I know it's a 29. My setup would look like this. Cosine of E is my adjacent 21 divided by my hypotenuse 29. What am I going to do to solve for E? Take the inverse cosine of both sides. So it's going to look like this. Calculator time. I don't know what that is. Inverse cos of 21 over 29. Let's see. Inverse cos of 21 divided by 29. If we go to the nearest tenth, that's going to be 43.6 degrees. Which makes sense that 20 and 21 are pretty close. If they were exactly the same, we'd expect 45. So what do we say? 43.6, I want to say. Yeah. 43.6 degrees. So now I know. Oh goodness, if I could type. I know two angles. I've got a 90 and a 43.6. Can you find the last one? D. Here's all we got to do. Every time, 180 minus the 90 minus the new angle that I just found, 43.6 degrees. That's going to equal angle D, right? It's the same algebra as the previous slide. I'm just kind of shortcutting stuff to cut down the time length. Okay, let's type that in. 180 minus 90 minus 43.6. 46.4. It makes sense that that guy is a little larger than angle E because the side opposite of it bigger, right? Opposite of D is 21, so opposite of E, which is 20, should be a smaller angle. They're super close in size, so I'd expect the angle to be darn close, and they are. We have now solved that triangle, and that was just one way to go about solving it. Okay? Let's jump to number 7. In this case, we're given two sides again, so we can still do some Pythagorean theorem. Okay? I'm going to copy my a squared plus b squared is c squared. What I now know is a is 91. I don't know b, my other leg, gj, in this problem. I don't know how big that is, but I do know the hypotenuse, 109. So in this case, b squared is actually going to equal 109 squared minus 91 squared. I'm just going to type that in the calculator and see what it gives me. So I'm going to do 109 squared minus 91 squared. These are big numbers. Calculators are totally okay. 3,600. So b squared is exactly, oops, come on, there we go. Can you guess what the square root of that guy is going to be? We take a square root of both sides to get it by itself. Second square root, oops, didn't hit the right button. Second square root of 3,600. Hey, it's 60. So now I've got b is 60. I've got all three sides. Good. Now I got to get all three angles. I only know one. I currently know the 90. I'm going to use the two original sides they gave me. And let's say I want to find angle G. If I want to find angle G first, right? I could find angle G or H because I have the hypotenuse, which means I couldn't use tangent if I were doing my angles first. I couldn't use tangent because from G I have 91, which is opposite, or if I'm looking at angle H, I have 91, which is adjacent. We just did a cosine on the previous one, so let's do a sine here. I can now say, actually I should do this a little bit. All right, sine of G is my opposite side, 91, divided by my adjacent side, 109. How am I going to find what G is? Take the inverse sine of both sides. Inverse sine of 91 over 109. I don't know what it is. You got to type in a calculator. Let's do inverse sine of, oh, that's just regular sine. Be very careful about that. That's going to give you very different things. It does need to have that inverse. Inverse sine of 91 over 109 is going to be, what does it say, 56.6 if we round to the nearest tenths place. We got 56.6 degrees for angle G. For time's sake, can you figure out how to find angle H? It's going to be the same deal. 180 has to equal 90 plus 56.6 plus H. You could do the same algebras on the previous slide, or you could do 180 minus 90 minus 56.6. What's that going to give you? What's it going to be? 50, that'd be 40, so what, 34.4 degrees? There you go. You solved it. You got all three sides, you got all three angles. All right, let's see what we got next. Let's see which more. Yep, all right, we're close. Gonna double check what we have coming. Okay, so we got two that we'll practice here. Page 550, example 4, because these are going to do it a little bit differently. In this case, it still says solve the right triangle. Round decimal answers to the nearest tenth. We've been doing that the whole time. But I've already given you one angle. Well, if you have a 90 and a 25, you can find G right away. Right? That's not going to be too bad. Just like what we were just talking about. G is going to equal 180 minus the 90 minus the, 25. What's that going to come out to? 95, that should be what? 65 degrees. Didn't have to do anything super crazy for that. G is just 65. Because we already had two angles, you could find the third just by subtracting the previous two from 180. So let's go ahead and move this over here. All right, you could double check 65 plus 25, that's going to be 90. 90 plus 90 is 180. So I'm going to leave this here, but I'm going to do the rest. I'm going to find G and H without using that 65. Let's say I wanted to find, I guess I'd probably have to go for H first, the side H. I guess I could do G or H. Really, it's not going to make a difference because now we have all the trig functions. Let's say I wanted to find side H first, okay, that lowercase. What I could say is that's the opposite of angle H. So if I said sine, the opposite is going to be side H over the hypotenuse. Oops. We already know that guy's 25 degrees though. So sine of 25 is H over 13. From that 25, my opposite side is the blue H. The hypotenuse is 13. We saw plenty of this sort of stuff last week. What do you do to get basically H by itself here? Multiply both sides by 13. I don't know what that is. Type in a calculator. Now it's basically just like one of those last week problems. These are going to have you put a lot of different pieces together. We have 5.49 is going to round to 5.5. That's how big that opposite side is. Now, if it's something where you only have one side length, I would not recommend doing Pythagorean right here. Because we rounded that 5.5, numbers start to get off just a little bit. Let's just do another trig to find G. I'm going to copy the same basic setup, except from that angle, G is now the adjacent side, so I'm going to switch to cosine. Cosine of 25 is going to be my adjacent G divided by my hypotenuse 13. It's the same setup, it's the same problem, except we just changed the trig function. So what does the algebra look like? Multiply both sides by 13. It was being divided by 13, so you multiply both sides by it. What's 13 cos of 25? Just like last week, you just got to go type it in a calculator, see what you get. 13 cos of 25, 11.8 is what we're going to call that because we're rounded to the nearest tenth. We have all three angles, 90, 25, 65. We have all three sides. 5.5 is H, 11.8 is G, 13 was given. It's the same thing. It says solve the right triangle, find all three sides, find all three angles. We have to give you basically three pieces of information and you can find the rest. All right. And yeah, we'll skip that guy. Okay. Last one for now, page 560, monitoring progress number 8. It's another similar sort of problem here. However, we've only given you one angle, 52. We've given you one side, 85. Nothing here is really labeled, so it's up to you to determine with these relationships a little bit. Since I already have a 90 degree and a 52 degree, I'm going to find out angle Y right away. Angle Y, because it's the third angle in a triangle, is going to equal every time 180, which is the total. I'm going to subtract away the 90, and I'm going to subtract away the 52 to see what's left. I showed the algebra in that slide 3 or 4 ago. You can repeat that, or if you just realize it's always going to match this pattern, I'm fine with it. Right? The properties of 180 degrees in a triangle isn't anything super new. It's going to be 90 minus 52. 90 minus 50 would be 40, so it's going to be 38. Y is 38 degrees. Type in a calculator if you want, that's fine too. Oh, my little dog woke up from the nap there. So we got Y is 38 degrees. Hooray. Let's go ahead and copy this over here. I've got all three angles. Now, I'm going to find, let's say, side YZ at first. From the 52 that I was given, and you could use the 38 now. That's totally okay. I'll actually show that. Let's say that I was to use the 52. YZ is the opposite side, and I know 8.5, the adjacent side. What's going to relate opposite and adjacent? Tangent. So I could say tangent of x is going to equal, say, YZ divided by the 8.5. Okay, so what I would do is I'd multiply both sides by 8.5 to get YZ by itself. We'll type that in a calculator in a second. That's going to give me how big YZ is. Let's say you wanted to find YZ using the 38 degrees that you just got. from 38, I know 8.5. I don't know YZ. 8.5 is opposite, YZ is adjacent, so I would write still tangent, but it's now tangent of Y would equal 8.5 divided by YZ. Again, we're kind of seeing some, this is algebra from basically 2 weeks ago. If I multiply both sides by YZ, because it's being divided, it's going to look like this. But I'm still trying to solve for YZ. So now I'd have to divide by, oops, sorry, I shouldn't say tangent of Y, I should say tangent of 38. Apologies. All right, I'm just doing algebra. Get YZ by itself. I'm going to divide both sides by tangent of 38. So it's going to look like this. Right now I have two different ways that I can get YZ. Let's check and see if they actually work out the same. First one, I'm going to type 8.5 times tangent. Oh, X I should have put in there as a 52. I forgot to replace these. I'm sorry. 8.5 times tangent of 52. 8.5 times tan. And this is regular tangent because I'm giving it an angle. I'm not giving it side lengths. I get 10 point, that'd be what? 10.9 if we rounded it. Let's try the other one. 8.5 divided by tangent now of 38. Close it. Oh my goodness, it's the same answer. How big is that last side there, YZ? What do we just say? 10.9. Whichever way you see it, as long as you're using the ratios correctly, you're not mixing and matching them, it's totally fine. I now know that YZ is a 10.9. I got to find one more side, YX. You could do maybe Pythagorean right here. I could do 10.9 squared and 8.5 squared. It's going to be a gross decimal. Let's just do a little more trick. Now, I'll go back to this guy right here. I'm going to use angle X, the 52. I'm going to use the 8.5, which is adjacent, and I'm wanting the hypotenuse. If I do 52 with my 8.5, my adjacent, and I want to match or find the hypotenuse, that tells me I got to use cosine. So I'm going to say cosine of that angle, 52, is going to equal to 8.5 divided by the hypotenuse, which is x in this case. Or I guess I should call it xy, right? I was using the full side length. What am I going to do to get xy by itself? Well, I have to get it out of the denominator. So I'm going to multiply both sides by xy. So it's going to look like this. Then xy is being multiplied by cos of 52, so I got to get rid of that now. Divide both sides by cos of 52. Let's type it in the calculator. At that point, I've solved what I need to solve for. I'm going to do 8.5 divided by cosine of 52. Hypotenuse, which should be bigger than both legs, is, what does that come out to? 13.8. So xy, how long is it? Oh, goodness. Too many things. 13.8. And did we solve the triangle? You better believe it. We got all three sides. We got all three angles. That's what we're asking you to do for this week. We're not going to mess with any word problems or this sort of stuff. Solving is pretty involved. Generally going to have to find three pieces of information. To boil it all down, you can use Pythagorean if you have two sides to find a third. If you know two angles, you can subtract them from 180 to find the third. You're going to have to do some trig somewhere. It could be inverse trig, like we started the lesson with, or it could be the regular stuff from the past 2 weeks that you've been working on. You've got to put all of these skills together when we ask you to solve them. Your task for the week is these guys. It's already built on Clever, so you don't have to worry about looking it up. If you go to your Clever assignment, it's page 561, number 3 through 18. Right, in some past weeks, I gave a mini quiz as well. This has that built in. Do all this practice. It's going to look exactly like what the quiz is going to look like. Okay. Take your time. Drop in office hours if you got questions with it. This stuff gets a little bit trickier. Please reach out earlier if you have questions. And as always, it's going to be on next Wednesday. I want to say the 6th. To any seniors, you guys won't have to worry about that that because your your final is going to be the 5th, Tuesday, from 8 to noon is when the window to take it. I'll kind of reach out to you directly and sort of set up a plan for what we have to do going forward.